In this video, we're quickly going to review the JBoss Windup reports. The first step is we will run JBoss Windup against a sample application. You can see here that I have an ear file. If I was tasked with doing a migration, the first step would be understanding what the ear does, and the second step would be actually understanding what I needed to migrate. How do we do this? I could go check out the source code for the ear and go through it file by file, but Windup doesn't require that I do that. With Windup, I simply point Windup at the ear file, run Windup, and review the report. So let's do that really quick. I'm going to jump into my command line. And I'm going to edit the jboss-windup shell script. You'll notice in here that we have a java-jar command followed by windup-cli.jar, and we're going to pass it the commands -fetch remote true, java pkgs, com.acme, -input, and a path to the ear file. If I do not put an output parameter, the output directory will mirror the name of the input directory. Let's run JBoss Windup. Now that Windup is complete, you'll notice that the directory now has an output folder that mirrors the name of the ear file. This is the Windup report. If we go and view the report by opening the index file, you'll notice several things. First, we're presented with a 10,000-foot view of the application. You can see here at the top that we collect a number of story points that reflect the effort to migrate this application. In this case, you can see these things are leading to an effort of 39 story points to migrate. You can also see that Windup has run recursively on the ear file. First, it started with the root of the ear, then it processed the JEE example services.jar within the ear file. Next, it moved on to the war file within the ear, and it profiled the lib files within the war file, as we can see here. Quickly, we can take a look at this report and see exactly what this application is made up of. First, Windup found that this particular JMS.xml file is actually a WebLogic JMS descriptor, followed by the manifest, followed by the ear application descriptor, a Maven POM file, and the WebLogic ear application descriptor. Scrolling down, we can see relevant information about the services jar. First, you can see that there's a manifest, followed by an EJB jar.xml, which contains a message-driven bean and 2 session beans. We have the POM file. We also have a WebLogic EJB descriptor. And within here, you can see several things. We have a classification of this Java class, which is a WebLogic application lifecycle listener, which is proprietary to WebLogic. We also have proprietary WebLogic startup services, some JMX beans, which we would want to validate. We also have EJBs, both a session, a home, a local object, a local home. And we have several of those. So we have both an item lookup home and also a product catalog home. And if we scroll down yet further, within the war file, you can see that we have a manifest, the POM file. We also have some WebLogic specific use of classes here. We have a non-catalog logger, servlet authentication, and you can see throughout here we have JSF descriptor as well as a war and a WebLogic application descriptor. So very quickly we can understand what was used within this application. You will also notice within the 10,000-foot view that there is an indicator here that describes kind of a heat map of how much information would have to change in order to make this compatible with JBoss. And so you can see here in these two classes, actually quite a lot would have to change because there is use of vendor-specific application classes throughout the given class. From this, we can also drill down into the actual resource reports themselves. So if we click on this JMS descriptor, you can see it's fully syntactically highlighted here. You can also see that we have several links. So in this particular case, Windup generated a JBoss messaging equivalent for this XML file. We also have the indicator that this XML file is actually a WebLogic JMS descriptor. This is just so that as you're drilling through these things, if you're not familiar with the technology, we catalog it so that you can find more information. We can also drill down in this WebLogic application.xml, and you can see it too has been classified by Windup. Within the XML for EJB jars, we've called out the MDB and 2 session beans, and if we drill down into here, you can see that they were highlighted and pulled out of the content here. So this message-driven bean is noted here, as well as the 2 session beans. And similar to the XML files, we can drill down, and you can see that Windup has also generated in this particular case the JBoss EJB descriptor that should be equivalent to the WebLogic descriptor we have here. And we could drill down into that and actually see that descriptor. This pattern continues with Java classes. In this particular case, Windup cataloged that the class was using vendor-specific classes. We were able to decompile this class, and if we drill down here, we've done several things. The rules have classified the class itself as a WebLogic application lifecycle listener. We've also added some relevant links for migration tutorials. We've also highlighted within the source code, line by line, the vendor-specific use that we would have to migrate in order to be compatible with JBoss. In this case, you can see that we have a pre-start method that uses the application lifecycle event handler, and we have inline hints that are also syntactically highlighted to provide examples. And that's a high-level overview of the Windup reports. In the next video, we'll review writing rules for JBoss Windup and how they can be used to both enhance the reports and also assist with the migration effort.